All right, guys. So this week we're going to be covering radicals before we enter fall break. There's a lot of things to deal with radicals, but we're going to focus on sort of the general understanding of them, um, how they work, what they look like, how to add them, multiply them, solve equations with them in it, and things like that. So we're going to break this week up into portions, and I'll break these videos up into portions as well. So this first one will be about domain and simplifying radicals. All right, so let's first talk about the domain of radicals. Now, there's one general rule that we need to remember with radicals, and that's that we can't square root negative numbers. So I see in this function here that I've got the square root of x minus 4, and since x is a variable and it's inside this function, x could change the number inside that radical. So we don't want x to be something that would make a negative number inside that radical. And the reason we can't square root negative numbers is for this reason. So take the square root of negative 4, for example. This won't work because essentially when you're trying to do the square root of a negative number, you're asking this question. You're asking, what number could I square and it would equal negative 4? And there is no number like this. There's no number that you could square and equal a negative number, period. Because no matter what number you choose, every time you square it, it will always become a positive number. So let's choose 2, for example, right? If you plug in 2 here, well, we know that 2 squared is a positive 4, not a negative 4. So that wouldn't work. Well, then maybe you're thinking negative 2. Well, negative 2 squared is negative 2 times negative 2. And again, still equals a positive 4 because 2 negative numbers would always multiply to make a positive. And 2 positive numbers would always multiply to make a positive. So there's no number that you could ever square that would ever equal a negative number, period. So we can't let this end up being negative, this x minus 4. So what we're going to do, and it's pretty simple on all these, is we're just going to take what's inside this radical, in this case x minus 4, and set it up greater than or equal to 0. Because if we set it up greater than or equal to 0, then we are ensuring that it is not going to be a negative number, right? Any number that's bigger than 0 or is 0 would be positive. So now we're just going to solve and figure out what the x values can be. So when we solve this, we treat it like any other equation. We'll add 4 to both sides. And that will leave me with x greater than or equal to 0 plus 4 is positive 4. So this is my domain. This means that I can use any x value in this function that is bigger than 4 or equal to 4. So let's experiment just a little bit so we get a better understanding. Let's say I choose x to be 4, right? Because x can equal 4. And I put it in here into this function. Oops. So remember, the function's x, square root of x minus 4. I know there's a 1 on the outside, but we're kind of not focused on that at all because that's not really going to change anything. It's just, remember, we can't do the square root of negative. Since 1's not in the square root, not really concerned with it right now. I just want to make sure that my square root won't be negative. So if I put 4 in for x, then it's going to be square root of 4 minus 4, which is the square root of 0. And that's fine. Square root of 0 is 0. I can manage that, right? That works totally cool. Any number bigger than 4, let's try a number like 5, right? 5 is bigger than 4. Let's just see how that works. When you put 5 in for x, then you have square root of 5 minus 4, which is the square root of 1. And again, square root of 1 checks out. It's positive. I can work that out. Now, what I can't use is a number less than 4, because my numbers, remember, x has to be bigger than or equal to 4. So let's choose a number less than 4, and we'll see what happens, right? Let's choose a number like 3. 3 is less than 4, so if I put 3 in for x, then I've got the square root of 3 minus 4. 3 minus 4 is negative 1. So that's the square root of negative 1. Now, this doesn't work because you can't square root a negative number. So x itself could potentially be negative in some cases. It's just we don't want the result here to be a negative. When that happens, like I said, it won't work. We can't do the square root of negative numbers. So long story short, all we're going to do with domain functions or domain problems with the radical is just look what's inside the radical and set it greater than or equal to 0 and solve it at that point. So let's look at another example. So here, again, just focus on what's inside the radical. So what's inside the radical is 4 times x plus 3. Now, remember, we can't square root negatives. So what we're gonna do, we're gonna set them up the same way every time. Let's take what's inside the radical, which is 4x plus 3. And we're gonna set it up greater than or equal to 0. And then we'll just solve. So there's a couple things you could do here to solve, but I think for a lot of you guys, the obvious thing would be to distribute. So go ahead and distribute. That'll be fine. 4 times x would be 4x. 4 times 3 would be 12. So remember, that's still greater than or equal to 0. And just continue to solve. Remember, we're solving for x here. So let's not focus our attention on that term yet. Let's focus on moving this 12 to the other side. Oops. So we'll subtract 12. And that leaves me with 4x greater than or equal to negative 12. And then divide by 4. So x is greater than or equal to negative 3. And when I get my hand too close to the screen here, it glitches off a little bit. So x can be greater than or equal to negative 3. Now, I know you're probably thinking, x can't be a negative number. No, x can be a negative number. That's fine. We just want to make sure that when I put it in to my function, that my function doesn't become a negative number. So x has to be greater than or equal to negative 3. Just for experimental purposes, let's plug in the negative 3 for x and see what happens. So got the square root 4, and then we'll put negative 3 in for x, negative 3 plus 3. So this becomes 4. Now negative 3 plus 3, if you try to add those together, it's just 0. So we have 4 times 0, which is 0. Square root of 0 checks out. That's totally fine. Again, that works. If you plug in negative 2, it would still work. So, 4 negative 2 plus 3. Negative 2 plus 3 is 1. So you'd have the square root of 4 times 1. Square root of 4 times 1 is square root of 4, and that's totally manageable as well. You just don't want to use any number that's less than negative 3. You want to make sure that any number you choose would be greater than or equal to negative 3, because that's the domain that we worked out. So moving along, we'll do 2 more, just real quick. So this one, here's my square roots, 2x minus 1. So remember, we just want to make sure that whatever inside my square root is greater than or equal to 0. So take the 2x minus 1, set it up greater than or equal to 0, same as all the others, and just solve for x. So adding 1 to both sides leaves me with 2x greater than or equal to 1, and then divide by 2. This will leave me x greater than or equal to 1/2. So there's your domain. Any number that's bigger than 1/2 or 1/2 itself will work perfectly fine in this function. Any number less than that will not work perfectly fine. Let me use the same screen here to do my fourth example, because I don't think I made a slide for this example. So just ignore that one for now. But I want to do, let's say y equals 5 square root of 4x plus 1. So notice how I wrote this. The 5 is in front of the radical. The plus 1 is not inside the radical. The only thing inside the radical is negative 4x. I want to choose this because the other ones didn't have this. So the 5 and the plus 1 don't really matter here because there's no limitations to what they can be. My variable is inside the radical, and I just got to make sure that whatever I put inside this radical is, well, not negative, right? Or that the outcome of it is not negative. So same as before, focus your attention on what's inside the radical. So in this case, negative 4x, and make sure it's greater than or equal to 0. So same thing every time. I know the 1 here and the 5 are pretty distracting, but for the domain's sake, it's not going to affect us for our domain. So remember, anything inside the radical greater than or equal to 0. So when we solve this, there's another little trick that comes up here. So negative 4 dividing on both sides, get x by itself. 0 divided by negative 4 is still 0. But if you remember anything about inequalities, the sign flips because we divided by a negative number. So notice I'm dividing by -4. When I divide by a negative number, my sign flips. So my domain is x greater than, or I'm sorry, x less than or equal to 0. So x, basically, this says that x has to be a negative number. And how that works is because since inside my radical, it's already a -4x, if x is a negative number, then a -4 times that other negative number will make it positive, therefore will work perfectly fine. So I actually can't use any positive numbers for x, because if I use any positive numbers for x, like 1 or 2, then the -4 times that number will keep it negative, and I can't use it. So trust your domain. It's totally fine. X can be negative numbers. It's okay. It depends, obviously, case by case. But just to be sure, you can always take the values, plug them in, and see how they work. So x has to be less than or equal to 0. So let's choose like -1. What happens if I plug in -1? -1 technically fits in my domain, right? -1 is less than 0, so that's fine. Well, here's what happens. -4 times -1 is +4. And that would work perfectly well. Okay? So there's the idea with domain. I'm actually going to go ahead and end this video here just because I don't want it to drag on too long. But I'll go ahead and start another one covering simplifying radicals. So I'll see you guys then.